For the longest time, it's felt like the universe misplaced its keys, or maybe half of them. We had a pretty good idea how much normal matter, the stuff making of stars, planets, us, should be out there based on early universe models.
Right. Models based on the Big Bang and the cosmic microwave background. They gave us a budget, essentially.
Exactly, a budget. But when astronomers counted everything up, all the bright, visible stuff in galaxies, well, it only came to about half the expected amount.
It's been a fundamental puzzle, a real head-scratcher. We could account for dark matter, dark energy, these more exotic things.
But the ordinary stuff, protons, neutrons, electrons, half of it was just gone, missing in action.
Pretty much. Vanished from the census.
Well, get this. It looks like the cosmic search party might have finally found it. And that's what our deep dive is all about today. This potential huge discovery of the universe's missing half.
And we should clarify, when we say visible matter here, we mostly mean hydrogen, specifically ionized hydrogen, the basic building block.
Right, hydrogen that's lost its electron, so it's just protons floating around.
Protons and electrons, yes, but separated, existing as a plasma. And it's the most common stuff out there. So if you want to find the missing normal matter, finding this ionized hydrogen is, well, key.
Okay, so the news comes from recent reports highlighting work by a big international team of astronomers, astrophysicists,
Very large collaboration, yes.
and they think they've tracked down this elusive material. So our mission today, for everyone listening, is to really get into how they did it, what they found, and crucially, what it means for our picture of the universe.
Yeah,
We want you to come away really understanding
it
this.
sounds good. Let's start with the problem itself, this missing matter problem, or sometimes called the missing baryon problem.
Baryon meaning
Yeah.
protons and neutrons, basically,
Yeah.
the heavy stuff in atoms.
Correct. So as we said, the early universe physics, the cosmic microwave background analysis predicts a certain amount of this baryonic matter.
Okay.
But observations of stars, gas within galaxies, galaxy clusters, it all added up short, significantly short, like half short.
Wow. So a huge chunk of the universe's normal matter budget was just unaccounted for. How did these scientists finally maybe find it?
Well, this is the really clever part. They used a novel technique, not looking for bright things, but for the incredibly subtle effect of this missing matter on light from very distant objects.
Okay, so what kind of effect? And where were they looking?
They were looking in intergalactic space, the vast, vast regions between galaxies, and they were looking for these enormous, extremely faint, diffuse clouds of that ionized hydrogen we mentioned.
Intergalactic space. I mean, that sounds incredibly empty. How do you even begin to detect something super faint and all that? Nothingness.
Well, it's almost nothingness, but not quite. That was the challenge. The technique involves using quasars, those extremely bright cores of distant galaxies, as background lights.
Like cosmic flashlights.
Exactly. Perfect analogy. As the light from a quasar travels across billions of light years towards us, it passes through whatever material lies in between.
Including these potential hydrogen clouds.
Precisely. Now, hydrogen, even ionized hydrogen, interacts with light in a very specific way. It absorbs certain frequencies, certain colors of light.
Ah, leaving like a fingerprint or a shadow in the light spectrum.
That's it, a specific absorption signature. It's incredibly faint because the gas is so spread out, but with sensitive instruments and careful analysis of the quasar light.
They can tease out that faint fingerprint.
That seems to be what they've managed to do. And it wasn't just one or two detections. The reports mention large survey programs confirming this, finding what's described as an intergalactic mist of hydrogen.
A mist. So it's really spread out, not clumpy.
Very diffuse, yes. Which explains why it's been so hard to find before. It doesn't shine brightly on its own, and it's not dense enough to show up easily in a mission.
Okay, here's something that really jumped out at me. They found this hydrogen further away from active galactic cores than maybe expected.
That's a really interesting aspect, yes. The reports suggest it was found expelled further from active galactic cores than previously believed.
Which feels a bit counterintuitive, right? You'd sort of think stuff would clump closer to the galaxies where all the gravity is.
You might think that, yeah. Or that maybe it was hiding in the halos very close to galaxies. But these findings point towards it being in these vast, extended structures, potentially pushed out further into the intergalactic medium by processes happening within galaxies, like feedback from star formation or active galactic nuclei themselves.
So galaxies are maybe messier than we thought, throwing stuff way out.
It certainly suggests galactic processes influence the surrounding intergalactic environment over really large scales. This matter isn't just passively sitting there, it's part of a dynamic cosmic web.
Let's talk about the people involved. This sounds like a massive undertaking.
Absolutely. The first author mentioned is Boriana Hudziska, a Miller postdoctoral fellow at UC Berkeley.
And she had a quote, right? Something quite confident.
She did. She said, "We think that once we go further away from the galaxy, we recover all of the missing gas." Which is, a pretty bold statement suggesting they might have solved it.
But she also added a note of caution.
Yes. Importantly, she stressed the need for more careful analysis with simulations to confirm everything. Proper scientific process. You need to double and triple check, especially with a result this big.
Makes sense. And Simone Ferraro was also mentioned. From Berkeley Lab in UC Berkeley.
Right, a senior scientist there. And apparently, he'd seen hints of something like this in earlier data analyses he'd done.
Oh, interesting. So it wasn't completely out of the blue for everyone.
No, and he's quoted saying, "The measurements are certainly consistent with finding all of the gas. Having someone who'd seen prior hints find consistency adds, well, it adds weight to the claim."
And it wasn't just them. You said it was a huge collaboration.
Yeah, 75 scientists from institutions all over the world. Big science often needs that kind of global effort, pooling data and expertise.
And for anyone wanting to dig deeper, the paper's been submitted to physical review letters, and it's up on the RCF preprint server.
That's right. So the details are out there for scrutiny.
Okay, let's boil this down. Why is this such a big deal? Finding this missing hydrogen. What does it fundamentally change about how we see the universe?
Well, connecting it to the bigger picture, it's potentially a massive step forward for cosmology and astrophysics. It means we might finally be able to balance the books on normal matter.
Complete the cosmic inventory.
Exactly. For decades, we had this huge discrepancy, this large fraction of matter unaccounted for. That uncertainty hampered our models of how galaxies form, how they evolve, how the whole large-scale structure of the universe came to be.
It's like trying to understand a forest ecosystem when you don't even know about, say, all the fungi and microbes underground. You're missing a huge part of the picture.
That's a great analogy. Finding this missing matter helps fill in that enormous blank space on our cosmic map. It gives us a much more complete understanding of the ingredients and their distribution.
And the nature of it, these huge invisible clouds of ionized hydrogen surrounding galaxies, it just paints such a different picture, doesn't it? It wasn't hiding in some weird exotic form, but just spread out very, very thinly.
Precisely. It tells us a significant chunk of the universe's normal matter isn't locked up inside the bright bits of galaxies. It resides out there in the vast, dark oceans of intergalactic space.
Which is why it was so hard to see with older methods focused on, bright, shiny things.
Right. And the finding that it might be further out than expected, possibly pushed out by galactic activity, that hints at a more dynamic interplay between galaxies and their surroundings than we might have fully appreciated.
So for everyone listening, this really could be one of those aha moments in science, a fundamental piece of the cosmic puzzle potentially slotted into place. You're now more informed about, well, what the universe is actually made of.
It definitely refines that mental image. It's not just galaxies floating in a void. There's this incredibly vast, incredibly tenuous, but crucially important web of hydrogen connecting everything.
Okay, so let's quickly recap. The missing half of the universe's normal matter, mostly ionized hydrogen, seems to have been located, not in galaxies, but as vast, incredibly faint clouds in the space between galaxies.
Found using clever techniques looking at quasar light, confirmed by large surveys.
And this discovery potentially fills a major, long-standing gap in our understanding of the universe's composition.
A huge gap. It balances the baryonic budget, so to speak.
Which brings us to a final thought to leave you with. Now that we might know where this vast reservoir of intergalactic hydrogen is, what else can it tell us? Could studying its precise distribution, its temperature, its motion, reveal deeper secrets?
Secrets about how the first galaxies formed, perhaps? How the cosmic web itself assembled?
Exactly. Think about it, something so fundamental, half the normal matter budget was effectively hidden in plain sight, or maybe plain darkness, for so long. What other subtle cosmic signals are out there, just waiting for us to figure out how to listen?